you know. So, can we do 15?
We can do 15, especially if you tell me in which section.
Oh, 3.1.
Huh?
3.1.
1?
Yep, 3.1.
Which page?
101.
Page 101.
And I think I know how to do that.
But,
Maybe.
okay, you want to.
That's
Number
okay.
15.
Yeah, I think I can.
So let G be a group
But you can do it.
if G squared is equal to G, then show that G is identity.
Yeah, that's on my.
Okay. See, the point is that it's with groups like with ordinary numbers. If you have equality in ordinary numbers, AB is equal to AC, with additional provision that A is not equal to 0, right? Then you can cancel. Right? Why? Because there is A inverse. In groups, you don't have this exception.
Okay.
Because you don't have 0 in the group. There is this identity relative to operation. So don't be confused, because if operation is addition, then it is like this, right? And this implies that B is equal to C no matter what. But with plus, okay. So when you have this equality, G squared is equal to G, right? Can I rewrite it just to remind you about this? That this is G and this is G multiply identity.
Okay, so you're, okay.
Right? So now I can cancel by G.
Okay.
But of course you don't need to do it. You can just multiply on this side by G inverse, on this side by G inverse.
Good identity.
Okay?
Yeah.
That's it.
Okay.
So in this regard, groups are better because you don't have this exceptional value 0, you don't need to worry about it.
Okay.
But you started with generation, and
Well, yeah, because that's really my question, but you've done it a couple times, but I'm not totally comfortable with it.
with notion of generation.
Yes.
How about something like, is this beginning like y is S3 equal to that?
Yeah.
What? Which number?
It's not a number, like y is S3 equal to like this.
Ah,
That should
okay.
be nice.
Okay. Okay. So, no, but let's look at it again. So you have S3. So here is a list. But then now, B, A, B, A squared B. Yeah, that's the list. Right? That's the list. So that's the one way to do it. But that's a little bit maybe even confusing. Because in order to finish it actually, you have to add something. This by itself is not sufficient. Why? Of course, if you multiply, say, A by A squared, you don't have A cubed. It's not here. So you have to provide additional information. What is A cubed? You have to write that A cubed is identity. Right?
Why do I have to write A?
Because otherwise, how would you know what is A multiply A squared?
Okay, so I assume
It must be one of these elements.
Okay.
Must be one of these elements. That's one thing. Another thing, and that's even more essential, that in our case, for a 3, AB is not equal to BA. Because in principle, if you write just this, and you put AB equal to BA, okay, then it's also possible. You won't get a 3, you'll get, what is it? Z6. You'll get Z6. But of course, still, by the way, even here, what is B squared? We don't have it. What is B squared? We don't have it on the list. It's not clear, yeah? We have to add this one. Right?
Okay.
We have to put it. And again, it's confusing, because I also can put B squared equal to A. You understand? And then again I get Z6. So this kind of information, if I just have this list without multiplication table, there is a multiplication table apparently. It doesn't tell me much, okay?
Okay.
AB does equal BA or doesn't?
In S3, of course not. In S3, AB is equal to BA squared. Not A, well, I have AB, so it was stupid one. BA is equal to A squared B. If you have just this list, then you have to supply it with multiplication table, right? But there is a more compact way to express the same group. And that's what we did, and that's where generation, whatever. That's what I thought you were talking about. You have element A, you have element B, so that's your group. And that was C, right? Generated by two elements A and B, subject to relations. AQ is equal to B squared is equal to identity. And for example, I can write it in many different ways, and BA is equal to A squared B. Okay, this information gives you all of it. It gives you this list. You can recover multiplication table. This information is sufficient.
Okay. Like I did have to do the multiplication table and everything.
You don't know how to do multiplication?
No. I get that. I understand
Yeah.
that part.
Yeah, but again, in a 3, you can think about a 3 in completely different fashion. You can think that it's all bijections of set of 3 elements. And then you just have bijections. Of course you know how to multiply them. I hope at least, right?
Yeah.
You know how to multiply bijections?
Yeah.
Composition. That's easy. So that's it. That's it. No? Do you understand everything?
Yeah.
Here, there, everywhere. Do you have any questions?
Not in particular.
Not in particular. Okay.
What about page 114, number 18?
114, by the way, today I hear even worse than usual. So you should be gentle on me and speak loudly. So which number? 18? Number 18, because my left ear is completely plugged, you know, like. And it's interesting. It's every year in April, about a week or 2 weeks before the end of the semester, I have this problem with one ear or with another. Yeah, another case was when I was in prison once. It was in Mother Russia. It was the same story, you know. Before they let me out of prison, I had problems with the ear. Kind of bizarre.
Have you ever used a neti pot or nasal irrigation?
That was some technical question. Yeah.
Neti pot, nasal irrigation, where you put like a saline solution through your nasal passages.
Well, I tried it, but would it help me with the ear?
It's connected.
I know that it's connected.
Like when I blow my nose after using a like saline thing or whatever, it really hurts my ears. So I learned I can't do that. They told me not to do that in the directions, but I still tried.
Yeah, well, I was.
Anyway.
Let G be the group of rational numbers under addition, and let H be subgroups. Show that if H is not 0 and K is not 0, then H intersected with K is not 0. That one?
Yeah.
Okay, so this is specific of a group. Because in general it's not true. In general, if you have a group, it's quite possible to have 2 subgroups with intersection just identity. Identity is 0. In a 3, if you take subgroup generated by A, subgroup generated by B, intersection is just identity, right? So you have to use somehow that this is rational numbers, okay? So this is rational numbers. Now, so you have 2 subgroups, H and K, right? And they're both not equal to 0, right? Okay. So if they're not equal to 0, it's just to say that it contains non-zero element. So I'll say that H contains H, which is not 0. K contains K, which is not 0. Right? Now, so I just want sort of to walk you through the steps so you will have a little bit better understanding of not this particular problem, but life in general. So look, H certainly contains this subgroup. And K certainly contains this subgroup, right? Now, if the statement of your problem is correct, then these 2 subgroups must intersect by 0. Is it clear?
Yes.
Because who knows, maybe H is just this, and maybe K is just this. So instead of proving this general Mumba-Jumba, now you have the following. you have two rational numbers, h and k, both not equal to 0. Well, you know, I can write that their product is not equal to 0. You understand? Both not equal to 0. Somehow you have to deduce that this and this intersect not by 0. Okay, so what would be this? What is the subgroup generated by h? Well, can we write it in some reasonable way? It contains 0, it contains h, does it contain 2h? And 17h? Okay. So this we can shortly write as h multiplied by 0. Agreed? Where h is not integer, h is a rational number. And this is the same. So that's your question, that this intersection is not 0. Okay? Now, next consideration is that it's very important that h and k are actually rational numbers. If they will be irrational, then it's perfectly possible that this intersection is 0. Just think, this is square root of 2, this is square root of 3. Okay. Now, suppose I ask you different thing. Suppose h and k are both integers. Would you be able to do this? If h and k are both integers, can you explain to me that this intersection contains non-zero element? You may even know how to call this element. Actually, no, you certainly know the name. I'm not sure that it will pop up in your head.
Common
Brilliant. Least common multiple will be contained there. Okay?
Oops.
So it could be 1.
So 1 is not 0. Big
Oh,
deal.
okay. Yeah, okay.
And least common multiple is extremely rarely is 1.
Okay.
Right? When is least common multiple is 1? For 1, 1 and 1, negative 1, negative 1. But anyway, 1 is not 0. Okay. So, but what is h? H is h0 divided by h1. Now they are both integers. Agreed? And k is k0 divided by k1. And they're both integers, right? So would you agree with me if I write this inclusion? If h is h0 divided by h1, then certainly I can multiply this by h1. Yeah, it is here. And I can multiply it by 2h1 and by negative 17h1. So that's how I have this. Is it clear? Yes? Or no?
I think so, H1 is in H.
H,
Close.
these are both integers, and here are all integers. So when you are multiplying, you can decide to multiply not by all integers, but only by these integers, which is a subset of all integers. And then it will be this object. So what I'm trying to do, I'm pushing it step by step. So finally, you have these two things. And if our problem is correct, that's what maybe we were dealing from the very beginning with. Their intersection should be not just 0, and we already know what is this intersection. It contains, okay. And actually you had a problem once upon a time that h0 z intersected is k0 z, where these are both integers, is least common multiple of h. Do you remember it? You had this homework quite some time ago.
It was like one of the first ones.
One of the first, if not the first. Yeah.
Mm-hmm.
But it's in your situation. So what we did, we understood that if original problem is correct, if the statement in the original problem is correct, then it should be correct for very special cases where these two guys are just integers. And the idea here, of course, is that when h is fractional, it's sort of larger than just integer. Make sense? All of it? Okay, so ask me something else. Ask me something else. Well, what's going on here?
I had a question.
Oh, wonderful.
This is back to 2.3. I was
Which
just
one?
looking.
2.3?
Yeah, I was just looking at I was looking at my notes and I had this written down, and I think I must have a typo because I can't see how this is.
Which problem?
It's not a problem. It's actually just my notes as an example on the board. Just that line. That
What
equals.
was 3-7? That's a date?
Yeah, no, it's just a little
So the
cycles.
date is not important.
No,
Okay. What is important?
just the cycles or whatever.
Oh, 12, 3, 4. I'm copying it from your note.
Yeah.
Okay, and something is certainly wrong here.
Yeah. I must have
I'll
had a
tell you
typo on.
which part is wrong.
The middle part, because
Yeah.
it's not before.
But otherwise it's correct.
Oh, why did I write that then?
I think maybe because we discussed that this is permutation of set of 4 elements. 1, 2, 3, 4. And you wrote them here. That's what I
Did you write that
suspect
down
here.
last time? Like last-
No, this is
That's what
from
I suspect.
3.7.
Yeah.
Oh, wow.
That's what I suspect happened. What we are trying to illustrate here, that if we have 2 non-overlapping cycles, then it's not important in which order we write them. They affect the same bijection. No matter if you write it like this, it is bijection which exchange 1 and 2 and 3 and 4. And if you write it like this, it's the same bijection. That's later we spoke about commuting cycles, right? If cycles consist of non-overlapping elements, they commute.
And if they consist of overlapping elements,
Then they don't.
certainly don't. They never.
Well, let me think.
I guess that's not
They
that important.
certainly don't.
Oh,
Yeah, they certainly wouldn't commute. Yeah.
wow.
They certainly wouldn't commute. Yeah. But the point here, of course, is that non-overlapping cycles commute. And of course, you perceive cycle as a permutation, right? As a bijection. You just permute two segments. That's it. So, I think you just registered here
Okay.
that we're talking about permutation forever. Anything else?
I had a question on,
Yeah.
it's kind of like 2 parts, but it's not in the book.
It's okay.